Okay, so I want to do an example of a two-loop circuit diagram. You'll probably have this in the homework, on the exams, certainly in lab, and this is what they do in medical school, so you have to learn how to do this. All right, so don't look at that. Look at this. So this is what they'll give you on a homework problem or something like that. So you have a current. This piece of wire is I1. This piece of wire, I2. This piece of wire, I3, right? And so three currents. So in order to do the math, so you have three variables, right? Well, think of what you learned in algebra. If you have three variables, how many equations are you going to need? 3. So it's a 3-equation, 3 unknown problem. Forget it. Too much work. So we're not going to do that. We're going to learn a better way of doing it. All right? But again, this is what they would give you. All right, so what we're going to do instead, we're going to say we're just going to do a 2-equation problem. So we're just going to have 2 currents. We're going to be smart. All right, so we're going to say that this here, we kind of want to copy that as much as we can. So again, this wire is I1, right? So we're going to say this is I1, so that's cool. We'll keep that. Then this wire is I3. Yeah, we'll keep that. So we'll keep that. But then this wire, we're just going to use our head. Okay, think about it. If the I1 comes in, I3 comes in, therefore the current has to be this way, right? So we're just going to call it I2. Now notice the homework problem, I2 goes this way, our I2 goes that way. Who cares? We'll just put a minus sign later on, all right? But the beauty of this is, we know that I2 is just I1 plus I3, right? So, so we're going to solve for I1, then we're going to solve for I3, then we're going to just add them to get to I2. All right, now, so that's the first simplification. Because now we just have 2 variables, I1 and I3. So 2 equations, 2 unknowns. Now, remember, you always want to analyze the circuit in the direction of the currents. And that's why I set it up this way. So here, I1 is going this way, I2 is going that way, so we're going to analyze it in this direction. For the bottom one, I3 is going this way, I2 is going that way, so we're going to analyze it in that direction. And it just makes it easy. Okay, you'll see. All right, now, something else we can simplify. Look, here's a 2 ohm and a 3 ohm in series. Well, come on, just do it. It's a 5 ohm, right? Just, add resistors in series, you just add. So instead of having a 2 ohm and a 3 ohm, let's just put a 5 ohm, make it simpler. Same thing here. Here's a 1 ohm and a 4 ohm in series, so just call it a 5. And I'm not going to do any more than that. All right? So that just keeps it simple. All right, so goodbye. Okay, all right. And again, typically all they ever ask for is the magnitude. We don't really care about the sign. Because the sign is just direction. Who cares? You don't really care about the direction typically in a circuit diagram. You just care about the magnitudes. All right, so there we go. So we're going to concentrate on this thing. All right, and we're going to just use, the Kirchhoff loop rule. So here we go. So the top loop. So where do you want to start? I don't care. Let's start here. All right? So from here to here, we get plus 10. So you have 10. And then we go, remember, we're going clockwise. So here we go from minus to plus, that's plus 5. And then we go through this resistor, right? Okay, we go through resistor, so we lose voltage. So it's minus IR. So it's minus I. No, it's I. It's I1 plus I3. Agree? Because remember, this here is I2, but we only want 2 variables. We only want I1 and I3. So instead of saying I2, we're just going to say I2 is I3 plus I1, right? Okay, so again, start here. Plus 10, plus 5, minus 5 times the current. Minus 5 times the current. Then we go up here, and what's the current through this guy? It's just I1, so it's minus 5I1, and that has to equal 0. Okay, just the loop rule, right? Make sure you understand that. And again, the voltage is always negative when you go through a resistor, as long as your direction is the same direction as the current direction. If that's wrong, then you add. I don't want to do that, all right? Keep it simple. Always analyze your circuit in the same direction as your currents, then the voltage is always negative through the resistor. Okay, we're going to simplify that, so let's do it. So 10 plus 5 is 15. Okay, we have minus 5I1, minus 5I2, minus 5I1 here, minus 5I1 here, so we have minus 10I1, and we have minus 5I2. That's it, right? That equals 0. Let's divide. We get all these 5s and 10s. Let's divide by the 5. Keep it simple, right? So we have 3 minus 2I1 minus 1I2, right? So we just divide by the 5. Keep it simple, and then let's just get the currents on one side and the numbers on the other side. So we have 2I1 plus I2 equals 3. All right? So there's our one equation, and that we got that from the, why do I have a 2? Golly, Weber, 3. Sorry. Wow, that's really bad, right? It was super bad because I1 plus I3. Okay, so that's the equation from the top loop. And you can see there's two variables. So we have to get another equation, because how else can you solve an equation? If you have two variables, you need two equations. Let's do the bottom loop. Okay, where do you want to start? I don't care, it doesn't matter. So we're going counterclockwise. Let's start here, all right, for no good reason. So from here to here, we add 5. And then we subtract, right? We have to go through that 5 ohm. So we have minus 5, and I'm going to do it right this time. I1 plus I3, right? And we go down here, and this wire here is only the I3. So we have minus 10 I3, and then we're back to where we started. Okay, so we multiply it out. 5 minus 5 I1 minus 5 I3 minus 10 we don't have to do that, it's a waste of time. Let's just do it in our heads, come on. So we have 5. How many I1s do we have? Just minus 5. How many I3s? We have minus 5 there, minus 10, so we have minus 15. Okay, we have all these 5s. Divide by a 5. We have a 1 minus an I1 minus 3 I3 equals 0. Let's make it look nice, so get rid of those stupid negatives. So I have I1 plus 3 I3 equals 1. Okay, so we have two equations, two unknowns. Now you solve it however you want to solve it. I'll solve it the way I do it. You don't have to do it my way. You can do it whatever you want to do. Some people use substitution. It doesn't matter. I mean, really, you do what you want to do. Okay, so I'll show you how I do it. So the first one is 2I1 plus I3 equals 3. The second one is I1 plus 3 I3 equals 1, right? So two equations, two unknowns. Okay, so the way I do it, I like I don't know what you call it. I don't remember what you call it, but I'm going to multiply this second equation by negative 2. So multiply by negative 2. I'm going to just keep writing it over. It's a waste of time, but it's okay. So copy my first one. Okay, multiply the whole thing by negative 2. So negative 2I1 minus 6I3 equals negative 2. All right? Okay, just checking. Okay, now you add. Well, now you add. So that kills that. That becomes minus 5I3. That becomes 1. So therefore, I3 equals negative 1/5. Okay? Now, what's the minus sign mean? It means that I3 is actually going this way. I don't care, you know. The math is correct. That's all I care about. The math is correct. I don't care about the direction. All right, so now we got I3. We're not done yet, right? Now we're going to get I1. So what equation do you want to use for I1? Doesn't matter. Let's use this one. I mean, why not, you know? So I1 plus 3I3. So what's that? Okay, plus 3I3 is equal to 1. So that means that I1 minus 3/5 equals 1. So I1 equals 1 plus 3/5. So 5/5 plus 3/5 is 8/5. If we did it right, yeah, okay. So I1